This is Module 13. We're going to go through example 1. The problem reads as follows. Bob went to the Lego.com website in February and he recorded the number of pieces and the sale price for 157 Lego products listed there. The data is shown in this scatter plot. The best fit equation was found to be y hat equals 4.86 plus 0.1050x. So part A asks us to identify the explanatory variable and the response variable. So explanatory variable is the variable on the horizontal axis. It's the variable that represents the x in the equation. So in this case, the explanatory variable is the number of pieces in the Lego set. The response variable is the variable found along the vertical axis. It's the variable that's the y hat in our equation. So that means that in this case, the response variable is the price of the Lego set. Part B asked, would the correlation coefficient be positive or negative? Remember, correlation coefficient is positive if your data tends to be increasing, and your correlation coefficient is negative if your data is decreasing. And we see in this case, the data is clearly increasing, so the correlation coefficient would be positive. Estimate the correlation coefficient. Remember, your correlation coefficient will be close to positive 1 or close to negative 1 if your data is very similar to a linear equation. Your correlation coefficient will be close to 0 if your data tends to be more scattered and all over the place and not strongly correlated with a line. So in this case, our data looks very much like a line, a straight line increasing. So I would say our correlation coefficient is going to be very close to positive 1. So I might estimate the correlation coefficient to be something like 0.98. Part D asks us to identify the slope and write a complete sentence to interpret the exact contextual meaning of the slope of this regression line. So remember, the equation of our line was given up here to be y hat equals 4.86 plus 0.1050x. Also recall that equations of lines can be written in the form y equals mx plus b, or you could think of it as y equals b plus mx, where m is the slope of the line. So matching that up, y equals b plus mx. In our case, b is the 4.86 and m is the 0.1050. So since we're interested in the slope of the line, and we know that m is the slope of the line, and we know in our case m is 0.1050, we know that the slope of this line is 0.1050. Now we want to interpret the meaning of this slope in context, meaning we want to interpret the meaning of the number 0.1050 in the context of pieces and price. The first thing you want to do when you're trying to interpret the contextual meaning of a slope is to write your slope as a fraction. Our slope was the number 0.1050, which is not written as a fraction. But you can always rewrite your slope value as a fraction by just putting it over 1. So I have taken the number 0.1050 and written it as a fraction by writing it as 0.1050 over 1. The next step is you want to add units, contextual units, to the top and the bottom of your fraction. So how do we do that? Well, remember, slope is change in y over change in x. So I'm noting to myself in my fraction, the 0.1050 in the numerator is the change in y, and the 1 in the denominator is the change in x. That's how slope is defined, change in y over change in x. So what I'm going to do now is just add the units of y to the top and the units of x to the bottom. So in the top, our units of y are dollars of price, and our units of x were number of pieces. So the change in y is $0.1050 of price. The change in x is the 1 pieces of Lego box. The last thing I will do then is I will say this in context by understanding that this is describing to me the rate of change. It's saying every time that you go over 1 on this line, you go up 0.1050. Notice that 1 is positive and 0.1050 are positive. So the 1 represents traveling to the right 1 unit, and the Y change represents going up 0.1050 units. Putting that in context, it's saying if you increase the number of pieces in the Lego box by 1, you will increase the price of the Lego box by $0.1050. What does that really mean? $0.1050 is about $0.11, which is basically 11 cents. Increase by 1 piece, increase the price by 11 cents. So the contextual meaning is that every time you add a piece to a Lego box, you'll increase the price of the Lego box by 11 cents. You increase the price by 11 cents per Lego piece added. Part E asks to identify the y-intercept and write a complete sentence to interpret the meaning of that in context. The equation of our line is y hat equals 4.86 plus 0.1050x, which is written y equals b plus mx form. So the y-intercept is the b. Remember, though, y-intercepts are points. They're not just numbers. They're points. They're the point where this equation crosses the y-axis. Y-intercepts always happen where the x value is 0. So this line has a y-intercept of 0, b. And in this case, that means the y-intercept is 0, 4.86. To interpret this point in context, I will make sure I understand the meaning of the 0 and make sure I understand the meaning of the 4.86, and then I'll put them together. The 0 is the x value, and the 4.86 is the y hat value. The x value in this case represents Lego pieces, and the y hat value represents the price. So we're saying 0 Lego pieces and $4.86 price. So literally in context, it would mean that a Lego set with 0 pieces would have a price of $4.86. Of course, you can't buy a Lego set that has no Lego pieces in it. So really, in context, it means that this is an initial base price that's charged for each Lego set before any pieces are added. So it asks us then to find the predicted price and find the residual for a set that included 551 Legos. Notice it does tell us Bob recorded that a set containing 551 Legos cost $89.99. There is an observed data point on our dot plot that is 551, 89.99. That is observed data point in reality, an observed point from the sample. It asks us, though, to find the predicted price using our model, using our regression equation. Our regression equation is y hat equals 4.86 plus 0.1050x. So in this case, the x is the number of Lego pieces. The y hat is the price. So if you replace the x with 551 and find the value of y hat, it's asking what predicted price would you get. So if I plug into my calculator 4.86 plus 0.1050 times 551, we see we get 62.715. This is telling me that our model predicts that a Lego box will cost $62.72 if it has 551 Lego pieces. In reality, though, we were told that there was an observation where a Lego set with 551 Legos in it actually cost $89.99. So the model was a little off, which is always expected. It's not going to be perfect. The residual tells us about the actual error between the model's prediction and reality. A residual is always calculated by taking the observed y value in reality minus the predicted y value from the equation. So in this case, the observed y value in reality was $89.99 minus the predicted value was $62.72. If you subtract them, you get $27.27. So notice the observed value was actually higher than the predicted value. The predicted value was an underestimate. Our residual is positive, meaning our observed value was higher than our predicted value. The model was underestimating reality.